Hi everyone, myself N. Ankila, working as a assistant professor in Erodu Sengundar Engineering College, belongs to Biomedical Department. Today we are going to see about the heart lung machine. Introduction. The heart lung machine intercepts the blood at the right atrium before it passes into the heart. Using a pump, the machine delivers the blood to a reservoir which adds oxygen to the blood. The pump then sends the oxygen rich blood to the aorta and through the rest of the body. Extracorporeal circulation. ECG or perfusion is defined as a procedure carried out with the aid of HLM. In the early stages, cardiac surgery was mainly concerned with the treatment of congenital heart defects. Today, the main focus is on acquired heart defects. As a path to the operation area is kept as small as possible to reduce the patient's surgical trauma. This surgical technique usually has a direct influence on the configuration of the HLM and on the way the perfusion is carried out. OPCAB. This is off pump coronary artery bypass. Refer to cardiac surgeries carried out without the support of an HLM. The HLM can never be looked at in isolation. Additional components, mainly in the form of sterile disposables such as an oxygenator, heat exchanger, or reservoir, take other important functions during ECG. A heart-lung machine allows the surgeon to carefully stop the heart while still maintaining the blood circulation. Structure and function of the heart-lung machine is the HLM is the basis of ECG and cover two important organ functions. One is pump function of the heart, another one is gas exchange function of the lungs. It must ensure a sufficient perfusion volume that corresponds to the normal cardiac output of the patient under anesthetic. The machine consists of a pump which functions as the heart and an oxygenator which replaces the function of the lungs. Then an adequate perfusion pressure. The perfusion pressure range is 50 to 90 mmHg. It must also ensure sufficient oxygenation, elimination of CO2 and control of the blood temperature. The components make up the basic equipment of the ECG that is used during modern cardiac surgery. List of that: one is blood pumps, second one is oxygenator, third one is tubing system with various tubing diameters, fourth one is blood filters with various functions, fifth one is cardiotomy reservoir, sixth one is cannulae and intracardiac suction tubes. The machine consists of a pump which functions as the heart and an oxygenator which replaces the function of the lungs. Next one, need for heart lung machine. The machine circulates the essential oxygen rich blood to the brain and other vital organs during open heart surgery. Blood pumps and their function is blood pumps can generally be categorized into two groups depending on their function. One category is roller pumps, another one is centrifugal pumps. Essentially, both pump types should meet certain criteria when used with the HLM. Dosed delivery of liquids with the precise display of the actual flow rate and delivered volume. External control mechanism. This is monitoring functions. Third one, sufficient pressure or vacuum generation. Next, minimal blood damage. Then adjustable occultation settings. This is nothing but a roller pumps only. Next, pulsatile flow generation, high efficiency, high reliability and safety, option for emergency operation, example manual operation. Allowing the cardiac surgery team to operate a heart that's blood free and still. When the surgery is complete, the heart is restarted and the heart lung machine is disconnected. Purpose of defibrillation. The main component of a heart lung machine or a pump to provide the driving force to the blood in the atrial system. So, an oxygenator for exchange of oxygen and carbon dioxide and a heat exchanger to allow control of temperature of the body. First one, roller pump. DeBakey blood pumps are based on the displacement principle and deliver blood through a tubing segment from the pump housing using rotating rollers. The roller pump consists of rotating pump arm with two attached cylindrical rollers, pump housing into which a semicircular silicon tubing segment is inserted and then secured using special tubing insets. The rotating rollers alternately compresses the tubing segment and deliver the liquid contained in the tubing in accordance with the rotational speed and direction. The exact adjustment of the two rollers determines the delivery. Rollers move outward symmetrically and block the inserted tube evenly to reduce erythrocyte damage caused by shear stress or direct crushing. Blood returning to the heart is delivered through the machine before returning into the atrial circulation. The one is San Francisco in one of the scariest parts of the bypass surgery, having your heart stopped and going on heart lung machine while doctors fix your clogged arteries is safe even in the elderly and does not cause mental decline as many people have feared. Two landmark studies shows. Next, principle of heart lung machine. Centrifugal pumps and the principle of heart lung machine is forces to transport to blood instead of tubing compression. Because of the technical principle of operation, the centrifugal pump has a limited application. Centrifugal pumps have the advantage of delivering limited amounts of air causing less blood damage in the long run. An additional flow meter is required to determine the delivered flow is a disadvantage. Next one, the, that early machine, while functional, still was open to improvement. For one thing, it required many pins of blood to prime the machine, and it was bulky and took up much of the room in the operating room. Since then, the size of the machine has been reduced and the need for blood to prime the machine has been dramatically reduced to only a few pins. Oxygenators and gas exchange function. In oxygenator, the artificial lung, also called the oxygenator, takes one the lung function during ECC and is therefore responsible for the exchange of vital gases. The membrane oxygenators are now used as standard. They contain a semi-permeable membrane in the shape of a microporous hollow fiber. This liquid impermeable membrane separates the gas side from the bloodstream. Due to the partial pressure gradients, oxygen and carbon dioxide diffuse through the microporous membrane. Today, most membranes are made up of polypropylene or polyethylene and permit operating times of 6 to 8 hours. The oxygenator must be able to oxygenate about 5 liters per minute of venous blood from 65% of oxygen saturation to above 90% of oxygen saturation before the blood enters the body systems. The oxygenator consists of one is a cylindrical glass vessels of 15 cm internal diameter, 38 cm long, 80 to 100 stainless steel disc of 0.6 mm thickness and 14 cm diameter are mounted axially with 3 mm spaces between discs. The shaft on which the discs are mounted is hollow and is supported by 3 ball bearings at the end. The oxygen is fed through the axis of the shaft and it enters the oxygenator through the distributing aperture on the circumference of the shaft. The oxygen feed system permits use of disc diameter close to the diameter of the oxygenator cylinder so that for a given blood priming volume, maximum utilization of the available surface area is made. The optimum blood level in the oxygenator that provides the maximum film area for a given volume of 0.7 or bar or is the radium of disc. One mechanism, in addition, the heart-lung machine was rapidly improved in other areas. Oxygenation, for example, was accomplished by more sophisticated methods. Once patients could be kept alive during heart surgery, a whole new range of operations became possible. Tubing systems for extracorporeal circulation. The tubing system is used to connect the individual components of the extracorporeal system and forms a closed circuit with the vascular system of the patient. Depending on the location, either PVC or silicone tubing is used. Tubes are available in different diameters and wall thicknesses. Tubing sizes range from a diameter of 1 divided by 8 and a wall thickness of 1 divided by 16 to 3 divided by 16 and 1 divided by 4 for pediatric applications with correspondingly low flow rates. Tubing for adult application is usually the range is 3 divided by 8 or 1 divided by 2 with a wall thicknesses of 3 divided by 32, facilitating flow rates of more than 101 per minute. Function of blood filters. Blood filters are integrated into the ECC system mainly to avoid microembolisms caused by autologous effect, foreign particles and microbubbles. Congenital heart defects could be repaired, diseased or damaged valves could be replaced, and coronary bypass surgery become possible through sieving in a replacement blood vessels to carry blood flow around a blocked section of artery. Next filter is depth filters made of Dacron hole or polyurethane foam are inserted into cardiotomy reservoirs and are used mainly for partial filtration. The pore size can vary from 80 to 100 microM coarse separation of particles. Third one, mesh filters made up of a mesh of woven polyester strands used as arterial blood filters and work on the principle of series. The pore size of mesh filters ranges from 20 to 40 micrometer. Unlike depth filters, mesh filters have little adhesive forces. There are retention properties are excellent as air bubbles can only pass the filter medium when a certain pressure difference bubble point pressure is reached. To function, the heart-lung machine must be connected to the patient in a way that allows blood to be removed, processed and returned to the body. Therefore, it requires two hook UPS. One is to a large artery where fresh blood can be pumped back into the body. The other is to a major vein where used blood can be removed from the body and passed through the machine. Cardiotomy reservoir. The function of the cardiotomy reservoir is collects and filters the blood aspirated from the operation area and feeds it back into the ECC as required. Second one, provides volume storage. Third one, the transparent housing facilitates continuous level control. Fourth one, a detailed scale makes it easy to quantify the level and detect corresponding changes in volume. A minimum residual volume always remains in the reservoir during the entire ECC to prevent air delivery into the extracorporeal system. Next one, cannulae. Cannulae are the interface between the ECG system and the vascular system of the patient. They are inserted into the relevant vessels by a surgeon, where they are secured and deaerated before their sterile connection to the ducting system of the HLM. Two types of cannulae. One is arterial cannulation, another one is venous cannulation. First one, arterial cannulation, are used to return the oxygenated blood to the systemic circulation of the patient. The aorta ascendens is the most frequently used site. The type and size of the selected cannulae depends on both the required blood flow and the anatomic condition. Second one, venous cannulation. Venous cannulae drain the patient's blood from the venous vascular system to the HLM. The type and size of the selected cannulae is determined by conditions that are similar to those on the atrial side. Bent catheters inserted to protect the temporarily arrested heart and especially the left ventricle from overextension due to blood flowing back from the bronchial circulation. Using this vent suction tube, excessive blood is drained usually via the auricle of the left atrium or into the cardiotomy reservoir of the HLM. The function, the heart-lung machine must be connected to the patient in a way that allows blood to be removed, processed and returned to the body. Therefore, it requires two hoops. One is to a large artery where fresh blood can be pumped back into the body. Components of the heart-lung machine is HLM basic components. Another one is additional HLM components. Mobile control for mounting multiple pumps. Adjustable mast system for mounting blood pumps. Control and monitoring devices. Then display and control panel. Electronic or mechanical gas blender. Anesthetic gas vaporizer. Electronic documentation system. Additional HLM components. One is water meters, another one is heater cooler device. During ECC, the heat exchanger of the oxygenator indirectly regulates the patient's body temperature by heating or cooling the blood flow. Patients can also be placed on a water mattresses that increases or decreases body temperature. Components of the heart-lung machine is mobile console, another one is adjustable mast system. In mobile console for mounting, the purpose of multiple pumps, the power supply, emergency power supply, last one is electronic parts. Second one of the heart-lung machine component is adjustable mast system for mounting the holders for the oxygenator, filter, cardiotomy reservoirs, external pumps and additional devices. Next one is ketones. In ketones, two types of atrium and isolated organs are contained. One is atrium, pleural atrium, one of two upper chambers of the heart. They are receiving units that hold blood to be pumped into the lower chambers, the ventricles. Second one, isolated organs. Organs removed from an animal's body from study. In this way, their function can be determined without influence by the organs. Components of the heart-lung machine. Blood pumps, larger roller pump, another one is small roller pump. In larger roller pump with a longer tubing path in the pump housing that produces higher flow rates required for the atrial blood flow, suction or vent pump. Second one is small roller pump. Pump with a shorter tubing path in the pump housing for lower flow rate, example, for the perfusion of infants and children or for the administration of cardioplegic solutions, usually a double pump. Third one is centrifugal pumps for the arterial blood flow. Components of the heart-lung machine. Control and monitoring devices include pressure monitor including sensors for measuring different pressure in the extracorporeal system and for controlling the flow rates. Second one, temperature monitor including sensors for measuring and displaying different system temperature and, if required, patient temperature. Third one, level monitor including sensors for measuring and controlling the volume level in the cardiotomy reservoir. Fourth one, bubble monitor in the form of ultrasonic sensors that regulate the flow rate of the affected pump when air is detected in the system. Pulsatile flow control for creating and controlling a pulsatile flow profile. Sixth one is cardioplegio control including pressure and bubble sensor for controlling cardioplegio delivery. Time for measuring important times and intervals during perfusion such as total perfusion time, aortic clamping time and reperfusion time. Through the body and is in need of oxygenation. Another connection is backed by shunting into the aorta. The main artery leading from the heart to the body, or the femoral artery, a large artery in the upper leg. Next one, blood is removed from the vena cava, passed into the heart-lung machine where it is cooled to lower the patient's body temperature, which reduces the tissue's need for blood. Next one, components of heart-lung machine. Display and control panel, providing access to all display and control elements described above as well as to additional system information and alarm management, electronic or mechanical gas blender. This is for controlling and displaying the ventilation gases, for example air, carbon dioxide and oxygen, that are delivered to the gas side of the oxygenator vacuum controller. For the precise control and display of a permanent vacuum on the venous reservoir. Components of the heart-lung machine is the anesthetic gas vaporizer, allowing and displaying the administration of a precisely dosed amount of anesthetic gas to the oxygenator. Second one, electronic documentation system that displays and stores all relevant data during perfusion. All data are stored centrally and displayed instantly as a perfusion report, which allows for data evaluation at a later stage for statistical and scientific purposes. Additional HLM components are heater cooler device. This is called also heat exchanger. The heater cooler device delivers water with a temperature ranging from 2 to 42 degrees Celsius. The heat exchanger contains two chamber pumps ensure that the delivered water does not cause a buildup of overpressure in the circuits. Two circuits supply the oxygenator and the heating cooling matrices. Third circuit is connected to the heart exchanger in the cardiac system. Two independent tanks with different temperatures, which allows instant switching from cold to warm or vice versa. Modern heater cooler devices feature several circuits with different temperatures. Heater cooler devices have always presented a hygiene challenge because the system parts that transport water inevitably become contaminated by germs. Regular water changes and the use of appropriate chemical cleaning agents are the two most effective cleaning and maintenance strategies. The blood receives oxygen, which forces out the carbon dioxide, and it is filtered to remove any detritus that should not be in the circulation, such as small clouds. The processed blood then goes back into the patient in the aorta or femoral artery. During surgery, the technician monitoring the heart lung machine carefully watches the temperature of the blood, the pressure at which it is being pumped, its oxygen content, and other measurements. Next one, when the surgeon nears the end of the procedure, the technician will increase the temperature of the heart exchanger in the machine to allow the blood to warm. This will restore the normal body heat to the patient before he is taken off the machine. This is full of content of heart lung machine. Thank you.